everyone, welcome to part 2 of Unit 1.1. Today we're going to look mainly at function machines, but before we actually look at those, I'd like you to try the remember task, okay, and that's going to allow us to come up with our rules for multiplying and dividing with negatives, okay? So have a go, then press pause, and when you're done, press play, and we'll go through the answers. Okay, well done. Let's take a look at question 1. It says that we need to finish filling this in. So 3 times 3 is equal to 9. 2 times 3 was equal to 6. 1 times 3 was equal to 3. 0 times 3 is equal to 0. Anything times 0 is 0. Okay, negative 1 times 3 is equal to negative 3. Negative 2 times 3 is equal to negative 6. Negative 3 times 3 is equal to negative 9. Okay? And looking at question 2, we had negative 3 times 3 is equal to negative 9. Negative 3 times 2 is equal to negative 6. Negative 3 times 1 is equal to negative 3. Negative 3 times 0 is equal to 0. Negative 3 times negative 1 is equal to 3. Negative 3 times negative 2 is equal to 6. And negative 3 times negative 3 is equal to 9. Okay, the question then goes on to ask us, it says, use your answers to explain what the rules are for multiplying with negative numbers. Well, if we look, a positive number times a positive number, sorry about that. Okay, a positive number times a positive number is going to give us a positive number. We had a negative times a positive number here, and those gave us negative numbers. We had, again, negative times positive, giving us negative numbers. Okay, and finally, negative times negative, giving us positive numbers. Okay, so we can come up with a set of rules for this. If I have positive multiplied by positive, I will get a positive number. Okay, if I have negative multiplied by another negative, then I will also get a positive number. If I have a positive times a negative number, I will get a negative number. And finally, if I have a negative number times a positive number, I will also get a negative number. Another way to help you remember this, if the signs are opposite when you do your product, then you will get a negative answer. If the signs are the same when you do your product or multiplication, then you will get a positive answer. The question goes on to say, would these rules work with division too? Well, let's have a think about working backwards. If 3 times 3 is equal to 9, then 9 divided by 3 would equal 3. All of those would be positive. Let's take a look at this one. If negative 1 times 3 is equal to negative 3, then negative 3 divided by 3 must equal negative 1. Okay, so that would mean a negative divided by a positive is negative. Well, that's good because that matches this. And finally, if we looked at 3 is equal to the negative 3 times the negative 1, then that must mean if I take 3 and divide it by the negative 1, I will get negative 3. Okay, so a positive divided by a negative gives us a negative as well. All right, so it looks to me like they match if we were to do division, which leads us to a separate set of rules that you need to write down as well, which is that a positive divided by a positive will equal a positive. A negative divided by a negative will equal a positive. A positive divided by a negative will equal a negative. And finally, a negative divided by a positive will equal a negative. All right, can everybody pause and write those rules down because they're really super important. Press play when you're ready to continue. Okay, so that sorts out our starter. What I would like to show you today is what a function is. And when we're looking at functions, we need to realize that it's a rule in mathematics. And what that means is it's an operation that we are going to apply to a number, possibly later on a letter, okay, to come up with a formula. But at the moment, we're going to concentrate on numbers. So for this function, which we can think of it as being a function machine, it's saying to us that we are doing 7, add 2 to get 9. So our actual function or rule is to add 2. If I wanted to have the inverse function, I would start with the output, which was 9, take away the 2, which is the opposite or inverse of adding 2, and that would give me my original question or original value, which was 7. Okay, so inverse should reverse the operation or the function, and that's why we call it an inverse function. Okay, so you need to pause the video and you need to take this down as a note, please, now, and then press play when you're ready to continue. Okay, well done for getting that sorted. Right, so this is our first try question. I'd like you to pause the video, okay? I'm going to make it full screen for you just to make sure that you can definitely see. And then you're going to try the questions, and then we'll go through the answers. So press play when you're finished, and we'll go through the answers. Okay, well done. Okay, so let's take a look at this together. Right, so it says to us that we should write down the inverse for each function machine. Okay, all right, so let's look at question 10a first. It says to us that we have 3 and that we are adding 5, and that will give us 8. So if we want the inverse, the opposite of adding is to subtract, so we're going to take away 5, and that will give us 3. Okay, so that bit there should have been your answer. Part B says we have 5, we're multiplying by 2, and that is going to give us 10. So if I would like the inverse, then the opposite of multiplying by 2 is dividing by 2, and that will take us back to the 5. Okay, and for part C, it says that we have 12, and that it is being divided by 3 to give us 4. So if we do the inverse, we start with the 4, we do the opposite, which is to multiply by 3, and that will give us 12. And finally, for part D, it said that we started with 9, we subtracted 4, and that gave us 5. So if we start with the 5, the opposite of subtraction is to add the 4, and that would give us the 9. Okay, so in each of these, the actual inverse functions were the opposite rules. Okay, so for part A, that was to take away 5. For part B, that was to divide by 2. For part C, that was to multiply by 3. And for part D, the inverse was to add 4. Okay, so if we can remember that inverse operations or inverse functions are the opposite operation, then that would be excellent. Well done. Okay, so good job on the try question. Okay, we're now going to have you apply that. So to make that full screen, you need to press pause, you need to try both of those questions, and then obviously press play when you're ready to go through the answers. Okay, well done. Let's take a look. Okay, so for question 11, it says write down a calculation to check each of these. Okay, so if you did add for 11a 387 plus 579 is equal to 966, one way you could check that is to do the inverse. So I could check that by doing 966 minus 579 and seeing if that equaled 387. Okay, so that is what I would do to actually check that. I say we do check that. You can use a calculator. It did say you could. So we'll do 966 minus 387, which is 579. That's one way to do it. Or, as we wrote down, 966 minus 579 is equal to 387. So we've checked that, and that means that the original calculation was correct because it works when we apply the inverse. Part B says we have 687 take away 598, which is equal to 89. Okay, so let's look at how we could test that. We've got two options. We could try 687 minus 89 and see if it equals 598. Or you could see if 598 add 89 is equal to 687. So let's do the second one. 589 plus 89 is equal to, let's check. 589 plus 89 is indeed equal to 600. Oh, no, it's not. It's equal to 678, which actually means it's wrong. Okay? It's a bit tricksy of them, but that is definitely wrong because it should have said 687. Right. Part C, we have 506 divided by 46 is equal to 11. Okay, so to check that, we do the inverse, which is to multiply. So we should check 46 times 11 and see if that equals 506. So let's check. 46 times 11 does equal 506, so we know that that one is correct. And finally, part D says we have 264 times 12, okay, is supposed to be equal to 3,168. I want to check to see if that's correct. Okay, so the inverse of multiplying is to divide. So let's see if 3,168 divided by 12 will give us 264. Let's check. 3,168 divided by 12 is 264. Okay, so we are okay. So the only one there that did not work out was B, so that was wrong. They should have written 678. Okay, that moves us on to question 12. Okay, and this one says, which is the correct calculation to check to see if 96 divided by 6 add 4 is equal to 20. So 96 divided by 6 plus 4 equals 20. Well, what we can do is think about the inverse, okay? So first thing we did here was divide by 6. That was step 1. Second thing we did was add 4. That was step 2. And we know we have to work in reverse if we're finding the inverse. So let's do that. I'll use green. That means that this is going to be step 1, take away the 4, and that step 2 will be to multiply by 6. Because we're doing the inverse, we have to use the opposite operation. So, keeping that in mind, we would have to start with the 20, and then we would take away 4, put that in a bracket because we do that first, and then multiply it by the 6. So our answer should be C. Okay, so I've also used the hint by drawing the function machine, looking at what we did in order, and then working backwards. Okay, so that's a really good technique for these types of questions. Okay, let's have you try the next one. Make that full screen for you. Can you please pause? Do the question, okay, you're allowed a calculator, and then we will go through the answers. Please make sure you follow the order of operations, so it should be brackets, then indices, then division and multiplication. Sometimes you can swap between, and then addition and subtraction again. Sometimes you can swap between, okay?